India is largely voice first. While millions rely on Indian Sign Language, that mismatch lowers classroom participation, slows hospital intake, and creates a friction at service counters and workplaces. With Spark, our focus is measurable outcomes, more successful two-way interactions, fewer interpreter bottlenecks, and more independent use minutes per day. Spark runs on device with low latency. It converts sign language to speech and speech to visual and add scene understanding with distance. The system is designed to operate continuously in real life environment, namely schools, hospital, transit points, front desks, and without depending on the cloud.
SPARC is modular and fault tolerant. The main orchestrator handles welcome input from microphone and keyboard, task selection, and return to prompt. The camera manager streams real sense RGB and depth in sync, both color and aligned depth. Object detection uses a YOLO model to draw boxes and labels on the RGB stream. The depth engine aligns Intel RealSense D55 depth to color and compute robust median distance per bounding box in meters. This powers proximity and alerts in scene awareness. The gesture recognizes uses CV zone and landmarks with feature combining all pairwise distances, among 21 points and local joint angles. 3ML model handles character, number, and words with a zero point 0.4 probability threshold and 1.2 cooldown. The OLED service handles 2 or 3 bold lines with persistent rotation and offsets. The audio uses blocking text-to-speech, so announcement never truncate. Critical alerts are mirrored to OLED instantly. Voice input pings the Bluetooth mic by name and echoes the recognized commands in the terminal. The safety layer adds real-time fault detection and pose motion cues and triggers live location sharing to predefined contacts with the fault when the fault is confirmed.
When a user says, "What can you see?" or presses 1, Spark opens two synchronized windows. First is the RGB detection with YOLO V8 at confidence 0.5 or higher. Second is a colorized depth view. For each detection, the system samples multiple depth values inside the bounding box and computes a robust median distance across a 10-second window. Spark aggregates unique classes and distances. At the end, it overlays results like chair 0.8 meters, bag 1.6 meters, speaks a clean summary through earbuds, and mirrors a concise line on the OLED. If depth isn't available, it announces detection only and continues gracefully.
Gesture mode triggered by detect hand gestures or E2 Spark tracks a single hand. The feature vector combines all pairwise distances across 21 landmarks with local joint angles. 3 train models recognize A to Z, 0 to 9, and a word set. We accept predictions at probability 0.40 or higher and enforce a 1.5-second cooldown to prevent jitter. Control tokens switch modes, character, numbers, or words, and backspace removes the last character or word. The OLED shows the current token and a rolling sentence in real time. After roughly 45 no hand frames, Spark finalizes and normalizes the sentence, speaks it out, and shows sentence completed on the OLED, and returns to the input prompt.
SPARC addresses a clear accessibility market in India. Our total addressable market includes about 79 million direct ISR or speech impaired users, plus institutional nodes, schools, design, hospitals, public counters, and corporates, reaching around 30 to 40 million indirect beneficiaries. Our 3-year serviceable addressable market focuses on urban and semi-urban regions across education, healthcare, public service, and corporate. DEI representing roughly 2.5-4 million people across 25 to 40,000 institutions. Our serviceable obtainable market over the same period targets 1 to 2% of the SAM, around 25 to 80,000 active direct users, and 500 to 1200 institutional nodes. Growth scenarios ranges from 10 to 24% CAGR driven by RPWD compliance, interpreter scarcity, smartphone ubiquity, vernacular UX, and offline first operation.
SPARC is designed for measurable inclusion. In education, we track higher participation, fewer interpreter requests, and more independent answer attempts. In healthcare and at front desk, we track shorter intake times for deaf users and better first contact resolution. In workplaces and public services, we track successful two-way interaction per shift, retention in training, and improved customer experience scores. The system is equatable by design, sign to speech, speech to visual without changing staff workflows. Offers first of for patchy network and privacy aware with all device defaults. SPARC supports the RPWD Act and aligns with SDG 3, 4, 10, and 11. In short, it is a reliable, measurable, and scalable bridge for schools, hospitals, and public service counters.
Hello, I am SPARC. Say mode 1 for object detection or mode 2 for gesture recognition. Then say start to begin.
Activate mode 1.
Mode 1 set. Say start to begin object detection.
Start. Done.
Recording completed. Processing results. I can see scene person detection completed with 29 scans.
Activate mode 2.
Gesture mode activated. Please specify gesture type, character, number, or word.
Activate word mode.
Word mode set. Say start to begin gesture recognition. Gesture recognition started. Recording for 15 seconds.
Done. Announce.
Word mode results. I detected the words no goodbye, hello, no, hello, no, hello, goodbye, goodbye.
Activate character mode.
Character mode set.
Start.
Say start to begin gesture recognition.
Start. Start.
Gesture recognition started. Recording for 15 seconds.
Done. Done. Announce.
Character mode results. I detected the letters B, Chi, Chik, Babab.
Number mode activate.
Number mode set. Say start to begin gesture recognition.
Start. Start.
Gesture recognition started. Recording for 15 seconds.
Done. Announce.
Number mode results. I detected the numbers 5543232101234555.